Hello, chemists. If you notice, there is one a bit longer problem on your assignment today that gives you these 5 givens. These are going to be constants. You're going to know these, but it says how many joules of heat are needed to change 40 grams of ice at 15 degrees Celsius to steam at 110 degrees Celsius. I changed the numbers, obviously, from the one in your assignment, so you actually have to do the work yourself. But I'm going to show you how to set it up. So we went over heat curves yesterday, and they look something like this, right? Now, what you need to know is that you're going to use your specific heat formula for the transitions on the sloped areas. That's where you're going to use the Q is equal to MC delta T. On these flat areas right here is where you're going to need to use the heat of fusion on this bottom one and the heat of vapor on the top one. So if you're going from a solid, which is down here, we know this, all the way up to a gas, you're going to have to cross through all of these. So I'm going to show you how that looks. So first you're going to start as a solid. And since we're dealing with water, we know that if we were to do the scale, we're starting at negative 15 degrees. But at 0 degrees Celsius is when it becomes water. Then you go up to 100 degrees Celsius, and that's when it's going to become a gas. So those are our break points, and then we're going to end up at 110. That's going to be important. So first, we have to do MCAT, because we're at this point right now. So we're looking for joules in all of them. That's our unknown. Our mass is always going to be 40 grams because we're not magically getting rid of anything. Our specific heats, those are given to us. We just have to change based on what area of the heat curve we're in. And then our change in temperature, a lot of people are going to be like, well, we go from 110 to negative 15, so ta-da, it's 125. But you have to factor in each part of the curve. So that's why we need to know this up here, because the first part, when we're calculating just the solid, this change is only 15 degrees. Then from liquid to gas is 100, and then just heating up this gas is going to be 10. So it's going to look something like this. You're going to set it up where we don't know Q. Our mass is going to be 40. Right now we are a solid, so the specific heat of ice is 2.09. And then our change in temperature, we started at negative 15 and we're going up to 0. So our change in temperature for just the ice is 15. We're going to solve for that. That's going to get us to this flat arrow of the thing. That's where heat of fusion is going to come in. It takes 334 joules per gram to transition from solid to a liquid. So that math is going to be 334 times our mass, which is 40. And that'll give us the joules for this transition. Now we're over here. So now we're a liquid. So we're still going to have 40 grams of mass because we're back to the MCAT formula. Specific heat of water is 4.18. And then we're going from 0 all the way up to 100. So we have 100. And that is going to get us up here to this transition. So next we have the heat of vaporization. That is 2,257 joules per gram. So we have 2,257 multiplied by our 40 grams. And that will transition us into a gas. But we're not stopping at 100. We have to go to 110. So we have to do a specific heat formula for the gas now. We still have 40 grams. The specific heat of steam is 209, or 2.09, I apologize. And then we were finally going this last 10 degrees. So what you're going to need to do in your calculator is you're going to calculate the answer for each one of these. And then, once you calculate all that, you're going to add those 5 answers together, and that is going to be your final answer. So let's use the calculator and figure this out. So first we do 40 times 2.09 times 15, and that'll get us 1,254. Then next we have 334 times 40. That'll give us 13,360. Then we have 40 times 4.18 times 100, which will get us 16,720. Then we have to go 2257 times 40. That will get us 90,280. And then last but not least, 40 times 2.09 times 10, and it'll get us 836. Then all we have to do is add these 5 numbers together. So we're gonna go 1254 plus 13360 plus 1676, or 720, my apologies, 720 plus 9280 plus 836, and will get us our final answer of 122,450 joules for this answer. So this is how you do it. You're going to use the numbers from your assignment. It's a lot of math, but there's only one of them. You can do it. These are givens. They're not going to change, so you can use these. It transitions at the same point, so you can use this. You just have to adjust your starting value and your ending value and your mass. Good luck. You got this.